Hello, how are human? Today we're going to look at the cardiac function and cardiac output. It's a little bit of very simple maths in this section, but nothing that should trouble you. So our learning intentions are to learn about the cardiac output and be able to calculate a number. So how many litres in a minute is pumped out of the heart. So you have to work out how many times the heart pumps, and every time it pumps, how much volume does it push out. So if you think about it, if you multiply those numbers together, you'll get the number of times the heart pumps in a minute, the volume per pump, how much it puts out per minute. It's very simple. You'll be able to take your pulse, hopefully. You'll be able to describe how heart rate will change under differing intensities of exercise. And you'll be confident with the cardiac output equation and be able to manipulate it in different ways. So starter question, see if you can name the 7 parts labelled here. Okay, so I would say 1 is the right atrium, 2 is the left ventricle, 3 is one of the AV or atrioventricular valves, 4 looks like the pulmonary artery, so it comes up here and branches right and left. Yep. 5 is a semilunar valve. This here would be another AV valve, and that's another semilunar. 6, if I can find it, that looks like the inferior vena cava, and that would be the superior. And 7 is probably going to be, so that would be the pulmonary vein. Yeah, that's pulmonary artery. Good. So the heart rate is how many times in a minute your heart beats. Normally, it's around 72. If you have a fancy schmancy kind of what's called digital watch thing, you might be able to press a couple of buttons, and when I do that just now, it tells me my pulse is 62. I'm obviously very relaxed. 65 now, I'm getting slightly stressed. 66, 71, I'm dead. Okay, so my average resting pulse is apparently 61, which is good. You can measure your pulse in the following way. If you expose your wrist, you follow your thumb down, you see your thumb is bony, follow it down until it hits your wrist. When it hits your wrist, you'll see there is a little bit just kind of underneath the thumb that is a bit bony on the left-hand side of your wrist, on the thumb side. If you put 3 fingers, if you move any watches that are on in that area, if you put 3 fingers just inside of that bone and lightly press in, you should be able to find your pulse. If you're fairly skinny, you may be able to push underneath your biceps to find your pulse, underneath your armpits, in your femoral region. You might be able to go under your patella, on your foot, or you might be able to find it just behind your windpipe in your neck. So there's lots of different ways you can find your pulse. So heart rate is how many times in a minute we beat our heart. The stroke volume is every time your heart does beat, how much blood volume is pushed out of your heart. So mostly we're looking at the volume pushed out of the aorta. So a normal volume would be about 70 milliliters in one push. So 70 milliliters is not a massive amount of blood, really. If you look at any kind of juice or a water bottle, you've got a lot more than 70 milliliters in that. So what we do is we multiply how often your heart beats in a minute with how much it pushes out every time it does. That gives us what's called your cardiac output. So the volume of blood pumped by the ventricles per minute, and it's determined by those 2 factors. Left and right should pump at the same volume, so it shouldn't matter if we're looking at aorta or pulmonary artery, unless you have a series of different medical conditions. Normally the value we get is around 5 litres, and I will show you some examples of that, and then you can have a go in your booklet. So at rest, your heart rate is about 72. Your stroke volume, so the volume per pump, is 70. So if you multiply those numbers together, you get something in the region of 5,040. Now, our cardiac output is in litres, so you need to divide that number by 1,000. And when you do that, you get 5.04 litres, or simplified to 5 litres. The cardiac output varies between individuals and depends on your fitness and level of activity. For example, a heart of a highly trained athlete might be able to pump 30 to 35 litres a minute. It might not always mean increasing the heart rate, it might mean increasing the stroke volume though. So most non-athletes can only achieve a maximum of about 20 litres, which is still quite decent. See if you can calculate your cardiac output, assuming a 70 mil stroke volume. So as I said, my pulse was about 60, so 6 sevens are 42. That's about 4 litres, 20, 200, whatever. So have we go at these word examples? Okay, so these are the answers. So 7 sevens 49, 7 twos 14 gives you roughly 5. 100 hundreds are obviously, and then the extra 10 is going to give you 11. 12 hundreds, 12 twelves gives you 13.4. 200, 150 gives you 30 litres. That's quite a lot. So use this technique to fill in the page in your booklet. Okay, so going through this. 7 sevens are 49. We have to then say 70 70s are 4,900, but divide by 1,000 to go from the mils to litres gives you 4.9. What number would give you 4.8 litres? Remember, this is in mils, so really that is 4,800 millilitres. So 4,800 divided by 80 gives you 60. Same token, 6,000, so 6 litres is 6,000 millilitres. 6,000 divided by 75 is 80. Basic maths. So you could try these questions, constructing a table to name the 4 chambers of the heart, the types of blood, so oxygenated or deoxygenated, found in them, where the blood has come from, and where the blood is going. We're now getting to the point where, with our understanding of the immune system and the inflammatory response, vasodilation, vasoconstriction, with our understanding of the different vessels of the body, you could draw a fairly decent high-level diagram that would cover exactly what the composition of the blood is, oxygen and nutrients and proteins at different parts of your system, what the blood plasma before you get to a tissue would look like, what the blood plasma as it's traveling through the capillary net would look like, and what it would look like the other side of the veins. You could compare the locations and functions of the AV and SL, or semilunar valves, atrioventricular valves, and distinguish between stroke volume, so the volume pushed out per minute, the volume pushed out every time your heart beats, so per beat, cardiac output, which is the volume pushed out by your heart per minute, and your heart rate, the number of times your heart beats in a minute. So cardiac output equals heart rate times stroke volume. This would be a good answer for the table question, and this would be good for the other two. In the next video, we look at the cardiac cycle. There's, again, a little bit of slightly complex stuff going on there, but I'm sure you will be fine.